Okay, so this is quadratic systems, page 1. Come up here. A system of quadratic relations is a set of, we're going to be dealing with two equations that can have constants, which are numbers like 34. They can also have x terms, y terms, x squared terms, and or y squared terms. They don't have to have all of these, but you can't have any power higher than 2 for a quadratic system. In other words, these equations are conic sections. They can also be lines, which actually are also a conic section. The solution to the system includes all of the points of intersection. This is stuff we've dealt with before. And again, you're going to either set these equal to each other or do some elimination. So I've got a circle. So what this says is with each circle, draw an ellipse to form a system with a given number of solutions. So 0 solutions means no points of intersection. So we need an ellipse. Well, okay. So I draw an ellipse which does not intersect my circle. I can also draw an ellipse here. I can draw an ellipse here. As long as they don't intersect, I've got no solutions. So one solution, well, one possibility would be to draw an ellipse like this. Another one would be an ellipse that looks like this, as long as they touch at only one point. So two solutions. That means they're going to intersect at 2 points. So there is one possibility. Here is yet another one. All of these, you notice, intersect at 2 points. Tell me I have 2 solutions. So 3. This one seems a little bit harder, but not really. I know I'm going to have 1, 2, 3. So in other words, this thing's going to come through. You just touch here and come through like that. Now there's a lot of other ones you can do, as long as it just touches once at one point and then goes through the other side. So 4 solutions. Let's take a look at that. I'd have to have 4 points of intersection. All right, so there we go. What's this going to look like? Well, we draw an ellipse like that. It intersects at 4 points. Okay, now we've got a hyperbola. Again, we're going to draw an ellipse. So remember, one solution means 1 point of intersection. 2 solutions means 2 points of intersection. 3 means 3 points of intersection. And 4 means 4 points of intersection. So no solutions means they're not going to touch anywhere. So geez, there's a bunch of these I can draw. Put one over here. I can slap one somewhere in the middle. Got a face now, don't I? But as long as they don't intersect, you've got nothing. One solution. Now, it means it's only going to intersect one of these at 1 point. So I could draw an ellipse which looks like this. Or I could draw one which looks like this. And there are a lot of other possibilities. 2 solutions. Okay, there's several possibilities here. So let's say I intersect each one at 1 point. So that would be that one. The other possibility would be that I intersect this one at 2 points. So I could have one like this. I could also intersect, say, at 2 points down here. As you can see, there's a lot of possibilities here. 3 solutions. Now what this means is going to have to intersect one of them at 1 point and the other one at 2 points. So that means this is going to have to be one end and then it goes through like that. And again, there are tons of these things you can draw. 4 solutions. So let's just say I want it to go through like that. It would be my ellipse. Okay, then we're going to come down for sample 3. Same idea. Zero solutions means no points of intersection. Again, we're drawing an ellipse, so I could put an ellipse like this. I could put an ellipse like this. As long as they don't touch, it works. One solution means they're going to touch at only one point. Or I could have it touch somewhere outside, like that. Two solutions means it's going to intersect at 2 points. So I can have something which looks like this. You can also have a parabola like that, as long as it only touches at 2 points. Three solutions. It's going to have to touch at a point and then 2 others. So there's a possibility. Another possibility would be 2 here, 1 here. 4 solutions means I'm going to have 4 points. Here's an obvious. And of course, I could draw these anywhere through here. Okay, so now let's pop over to page 2, because here's where the algebra comes into play. So we've got a system of equations, and we're going to do this by elimination. Elimination means adding both equations so one variable goes away or becomes 0. So let's take a look at this system right here. You notice we've got an ellipse. No, we've got a circle, which is this guy. And we've got a hyperbola, which is this guy. And if you take a look, we have 1, 2, 3, 4 points of intersection. Now, they notice here, if you take a look, these two y terms have opposite signs. So if we add these two together, what's going to happen is y squared minus y squared will give us 0y squared. So I end up with x squared plus 3x squared. That gives me 4x squared equals 2. 13 plus 3 is 16. X squared equals to 4. X equals to plus and minus 2. Okay, so we solved for my 2 solutions for x. So now we need to plug them back in to one of these equations, and I'm going to pick the one that's going to be easiest, which obviously is this one. So I'm going to find y when x is my positive 2. So I'm going to plug it in. So I'm going to end up with 2 squared plus y squared equals 13. Or 4 plus y squared equals to 13. Y squared is 13 minus 4 is 9. Or y is going to be plus and minus 3. And so all of my possible solutions to this then are going to be positive 2, and then a positive 3. And I'm also going to have my positive 2 and a negative 3. So there are 2 of my solutions. So now we come back up when we find y when x is negative 2. So now I'm going to have negative 2 squared plus y squared equals 13. 4 plus y squared equals 13. Y squared equals 9. Y equals plus and minus 3. And my solutions here then would be a negative 2, positive 3, and a -2, and a -3. And there are all four of my solutions. Okay, now let's come back up and take a look at this guy. And there are a couple of ways to do this. Now, one way to do this would be to multiply this whole equation by 9 and then adding it to the other one. Then that would work. The other thing you can do, and the way I did this, is to say, well, I've got 4y squared, so I'm just going to change the sign on all of these. So I've got to rewrite my system of equations now, which is now going to be 9x squared plus 4y squared equals 36. I'm going to change my equations. Now I've got an x squared minus 4y squared equals a -4. And then when I add these up, I'm going to end up with a 10x squared. These cancel out, equals 32. X squared equals 3.2, or x equals to plus and minus the square root of 3.2, which is going to equal plus and minus, approximately equal to plus or minus 1.8. Okay, so now we've got my x's, and we do the same thing we did above. We go in and we're going to plug x value in for one of these things, and it doesn't really matter. I don't really like having that negative there. So let's plug it in up here. So I'm going to have 9 times, and then I'm going to have the square root of 3.2 squared. I'm not going to use this 1.8 because this is the exact answer. I'm going to use the plus 1 of that. Plus 4y squared equals 36. And when I do that, I'm going to have 9 times the square root of 3.2 squared is just going to give you 3.2 plus 4y squared equals 36. And that gets me 28.8 plus 4y squared equals 36. 4y squared equals 36 minus 28.8. That gets me 1.8. Oh, and then I divide it by, no. Four y squared then is going to be 0.2, 17.2. Y squared is 1.8. Y is plus and minus 1.3. So now I list all of my, oh, and then I come back through and do the same thing. So I'm going to have 9 times a negative square root of 3.2 squared plus 4y squared equals 36. Okay, now, since I'm squaring a negative number, I'm going to get the same thing back out again. So this is also going to give me y equals plus and minus 1.3. So my solutions then will be, and I'll go ahead and use my approximations now. So I'm going to have a plus 1.8, and then a plus 1.3. Then I would have my plus 1.8 and my negative 1.3. Then I would have the negative 1.8 along with the positive 1.3. Then I would have a negative 1.8 along with a negative 1.3. 3. Okay. So now let's take a look at the last page, and this is with substitution, which means you solve one equation for one variable and then substitute in other equation. And this again is something we've been doing pretty much all year long. So if you've got square terms of x and y's, and this especially works well in something like this where I've got, in this case, I've got a circle and a line. See, I've got 2 points of intersection. But the problem here is, when you take a look at this, there's no good way to figure out how to add these up in order to eliminate one of the variables. As a matter of fact, there's no way to do it. Okay? And so typically, if you've got one of these things, this substitution is going to be really nice to deal with. So we're going to solve the linear equation for y because it's easier. So y is going to equal to 4 minus 2x. And we're going to plug that back in to y in the first equation. So I'm going to take this and plug it in for my y here. So I'm going to end up with an x squared minus 4x plus 4 minus 2x squared equals 1. So give me x squared minus 4x. And I'm going to expand this out, and this is what we've been doing with completing the square. So it's going to give me a plus 16 minus 16x plus 4x squared equals 1. And then I combine all of my like terms. So I'm going to end up with a 5x squared negative 4x minus 16x is going to give me a negative 20x. And then this has to equal 0, so we need to subtract the 1 over plus 15. All right, now I notice I can take a 5 out of all of this, and I'm going to do that. I'm going to divide everything by 5, so it's going to give me x squared minus 4x plus 3 equals 0. And so now let's go in and see if we can factor this thing, and sure enough, we can. This becomes x minus 3, x minus 1, equals 0. So I solve x minus 3 equals 0, x minus 1 equals 0, x equals 3, x equals 1. Okay, and there are my two values of x. Now, we still don't have our points of intersection. We need to get the y values. So we take these x values and we plug them back in up here. So I'm going to have 2 times, and I'll start with this one, 3 plus y equals 4, which gives me 6 plus y equals 4. Subtract the 6, give me y equals negative 2. So one point then is going to be 3, negative 2. And then I'm going to substitute the 1 in. So that's going to give me 2 times 1 plus y equals 4, or y equals 2. So my other point will be 1, 2. Okay, now this is where substitution really becomes a slick little trick, is on stuff like this. So I've got a circle and a parabola. Now again, you could, if you wanted to, go in and eliminate the 3y squareds by multiplying the top by -3, but it's really going to give you something really, really nasty. However, you'll notice I've got a y squared in both of these. So I can solve for my y squared in the first one. So my y squared is going to equal to 20 minus x squared. And then I put this in everywhere. Whoop, wrong one. I've got a y squared here. So I'm going to come back in now, and I've got 3 times. I'm going to substitute this in for my y squared. 20 minus x squared minus 2x equals 4. Then I distribute. So I've got 60 minus 3x squared minus 2x equals 4. And then I would like this to be a positive, so I'm going to move it on over. So I'm going to add my 3x squared. That's going to give me a 3x squared. And everything here now is going to equal 0 over here. Plus 2x. Now subtract my 60. And that will give me minus 56. Okay. So there's my quadratic. Now, if you remember, one way to do this is to do the a times c, which in this case is going to be negative 168. And then I want to try to factor x squared plus 2x minus 168. Okay, this doesn't look nice, but there is a way to do it. And what I did was I just went in. Now I know because this number is so small, these numbers are going to have to be close together. So I just sort of started out with 8 and kept going. And what I found was that 12 times 14 will give me 168. And this is just by trial and error. If you don't want to do it this way, you can always plug these into the quadratic formula. But that gives me 12, and so what I would end up with then is, remember this is the method I showed you where you break these things down. So now I'm going to write, now to get that I'm going to have a, and I start off with a 3x squared, so I write 3x. I'm going to have a plus 14 and a minus 12. And then you reduce these as much as you can. This one cannot be reduced, so my factors then are going to be (3x plus 14). And then this one I can divide by 3, which will give me a negative 4. I have x minus 4 equals 0. And so then you solve 3x plus 14 equals 0. X minus 4 equals 0. 3x equals negative 14. X equals negative 14 thirds. And x equals 4 are my two solutions. And so then I take both of these and I substitute them back in. And I'm going to put them back into the x squared plus y squared equals, no, I've got my x. I don't want to try to square these things. So I put them back into my 3y squared minus 2x equals 4. And I plug my x's in. So I'm going to have 3. No, I screwed up. Never mind. I did use the x squared plus y squared equals 20. And then I plugged them back in, so I'm going to have a negative 14 thirds plus y squared equals 20. And it's 14 thirds squared. That's going to give me 196 over 9, squaring both of them, plus y squared equals, and this is 180 over 9. Screwed up somewhere or other. Ah, no I didn't. So I subtract over, so now I've got a y squared is going to equal to 180 minus 196 over 9, or y is going to equal to the square root of a negative 16 ninths, which gives me I plus or minus I times 4 thirds, which means since this is non-real, it's imaginary, x equals to negative 14 thirds is extraneous. And I'll show you what this looks like. So this one is the extraneous solution. And now I'm going to test for 4, so I plug it back in. I want to have 4 squared plus y squared equals 20. Or 16 plus y squared equals 20. Y squared equals 4. Y equals plus and minus 2. So my two solutions then are going to be 4, 2, and 4, negative 2. And if we come back up and we look at our original graph, back up here, you notice we have two solutions which appear to lie on top of each other. That's my 4 and negative 2. We have nothing in the negative x value, which again tells you that that solution was extraneous and is not one we need to worry about. Okay, so this is what you're going to be doing. Elimination or substitution. My personal preference is when I can, I like substitution, especially when you're dealing with squared terms on both of them. If you can solve easily for one squared term and then put it back in. Now, if you try it one way and you end up with something really, really complicated, then go back in and try the other way. Now, one more point I'm going to make before I let you go. One thing you're going to have to do on these problems, and it's one thing I am seeing that is not happening in these classes, is that I have worked out examples for you. And then you come in and I don't get it. That's too bad. You're not going to get this stuff until you have the courage, the intestinal fortitude, to sit down on your own, take one of these examples and then take one of the problems I assign you and work it through one step at a time. Now, I can tell you right now that a lot of the people you think are smart are probably not any brighter than you are and do not necessarily get this at this point any more than you do. The big difference is that they are willing to sit down and work through the examples, modify it for what their problem is, and then get an answer. And if they can do that, then they own the problem. If I have to sit there and lead you through every problem, every step of the time, you will never understand what you're doing. However, if you will sit down and work through these examples and sit down and just do it, even though you don't feel good about it, work through one example. Then you go back through and you work through another example. And more often than not, by the time you get to the third or fourth problem, you've got this stuff solved. You can do this in your sleep. And that's the idea. Go back through, look at what you've got, look at the examples I have, and then start working through the problems based on the examples I have given you.